Hello Magnus, I am Simon's avatar, and I would like to present to you today the wonderful world of SimSys, and especially the agent called Simon the Sorcerer's Hat. Could someone please close the blinds? Thank you. First I will explain how the SimSys world is structured in an object-oriented manner. Then use Hans Jauer and Potbelly as an example to clarify how the agents in SimSys work. The main part of the presentation will be the behavior of Simon the Sorcerer's Hat. I will try to explain his features in depth, which is casting magic on his environment. As a conclusion, I would like to explain the advantages and disadvantages of the way Simon the Sorcerer's Hat creates his magic. So, basically SimSys is an object-oriented world, which defines rules. Within the limitations of these rules, the SimSys agents are free to move and interact with other agents according to their own rules. Each agent has its own rules according to which it acts in the world. But whenever the actions in an agent are in conflict with the rules of the world, these actions cannot be performed by the agent. For example, the world defines a rule that it has a certain dimension. There is a border where the world ceases to exist. To prevent agents from falling of the world, there is a rule that doesn't allow the agents to cross this border. So if an agent had the simple behavior of always walking straight ahead, it would eventually reach that border, and the world would no longer comply with the agent's request to move. Here we can see a class diagram of the application. The main class is the world, which is updated every frame. The world contains elements, which can be walls, food, agents, or speech bubbles. The agent is a special type of element. It is abstract, which means it is not fully defined yet. It needs further definition to work in the world. The class Hans Jauer and Potbelly is an example class, which inherits from agent and defines the missing update method. The class Sorcerer's Hat works in the same way. It just has another definition of the update method to make it act differently than Hans Jauer and Potbelly. The agent class also has two types of relationships with the speech bubble class. One points to the speech bubble it says, and the other to the ones it hears. The behavior of the agents are implemented in a state-driven manner. Hans Jauer and Potbelly searches for food when he is in a hungry state, eats when he found food, and speaks greetings when he is in a good mood and curses when he is not. The Sorcerer's Hat works in a similar manner. It walks around, eats, and casts magic on his surrounding elements in the form of lightning strikes and earthquakes. The interesting part is, of course, how this magic works. For the lightning strike, first the hat needs a target, then it creates the procedurally generated lightning sprite to charge the target agent. The sprite is generated procedurally in order to have every lightning bolt look unique. The next couple of slides will explain how this is done. The ingredients needed for a nice real-time generated lightning bolt are listed here. We need a gradient, some purling noise, or clouds, or gradient noise, a difference filter, some colors for good taste, and a pinch of optimization. So, first we will create a new bitmap and fill it with a linear black to white gradient. This is done by iterating through the pixels and setting their values according to their position. Next, we will create some clouds with the purling noise method, which is included in Flash. Now we can calculate the difference of each pixel's value from the linear gradient to the cloud's image. Once the resulting image is inverted, it almost looks like lightning. All that needs to be done now is to copy the pixels with high value to a transparent bitmap and add some color. Finally, this whole process can be optimized to work within a single iteration after creating the per-line noise. Another optimization that can be done is, since color is added in the end only, the first steps can be made with only 8-bit pixels, defining only the color value and not hue nor saturation. Only the last step requires 32-bit pixels, 8 bits for each color channel, red, green and blue, and 8 bits for transparency. Here you can see examples of the resulting sprites. The earthquake is not quite as complicated magic as the lightning bolt, but also has a nice effect. In order to work, searches all elements in the range it affects and lets them shake for a bit. As a conclusion, Here are some advantages and disadvantages of generated sprites in Flash. The first thing that comes to mind is of course the variety. Every generated sprite looks a little different than the other. Another positive thing is the download speed of the Flash movie. Since the sprite is generated on the viewer's machine, it doesn't need to be downloaded. The downside is the CPU time needed. If the viewer is on a slow machine, this might be a problem. This problem could be solved by caching a generated image and using that as a backup if there is no time to create a new image, or by always creating new images when there is some spare CPU time. Well, that was it. I hope you enjoyed this presentation. I hope it was not too robotic. And in case you have any questions, you are welcome to ask simon.broggi@gmail.com. Have a nice day. Bye-bye.